Right, just it's part of the progress right now. A little bit of update. These are the pads that I cut from this with my scissor, and I bent them manually, and I didn't solder them yet. That's the next stage. Solder and put there on all this pad location. And you see barely a circle there. That's the transistors. These transistors, they will live here, and like that, with the 3 pins in this position, and pretty much. This is the cardboard as it is. All the modules, button modules, are glued, but I made a mistake and I didn't test it originally. I did a big mistake by choosing this cardboard from Colgate. If you know this brand, Colgate, from wash. But the problem is, the mistake is that this cardboard is extremely flexible, is extremely bendable, especially with this weight. This little bit of weight that is having is extremely flimsy. Fucking hell! And I don't want to stress it more than it is. I will continue doing it on it. I can actually change everything. I can unglue, take out all these boards, and find another cardboard. But I made some calculations, some stuff here, and I like that is very long, and I can add on it, even if it's so very, very bad cardboard. I really don't like this cardboard, but probably it is so flimsy. Why? Because it's so long. That's why. That's one point. And the second point is that is probably made from recycled, I don't know, wood. Usually cardboard and paper is made from wood with some adhesive in it. They mix it like a paste and leave it to dry out. That's what I know, but I don't know exactly the process how they are making it. But I strongly believe this is a recycled cardboard, and it's very, very bad. It's not strong at all. It's very extremely flimsy, and I didn't check it, and it was my mistake. My idea is to reinforce it, but not right now. Right now, I will continue adding everything that I planned to add. Most probably, these chips will go on the other side and on the back of the board, and and probably I will add a metallic band like that, or even wood, but wood is too thick. Metal is very thin and very strong, and it will reinforce all this cardboard film badness that I have here. It's very, very bad, and I know it. But other than that, I tested every LED, and everything is correctly put, and I tested everything just to be sure that everything was correct. Actually, I made this 100 kilo resistors. I had a few mixed of 100 ohms, but they were having a kappa, a K on them, and I confused them being 100 kilo, while in reality they were reboot bad resistors, bad markings on the resistors, and they were 100 ohms. And this LED in particular didn't lit up, and I was very sure it was burned. And when it crossed my mind, after I took it out, it crossed my mind to actually test it alone, and it was working. So it's something there funky, and it was that fucking resistor after all that was having a K on it, but it was 100 ohm, so bad marking, and I scratched that K and put it back to its box in 100 ohms box. Here are all my boxes. Not really all, because I have there another 3, those 3, and all the values that I need of resistors. So yeah, and I repaired it, I changed it, I put 100K, now it's in order. It is a hard project actually. I made a 3D pre-visualization. How before I'm cutting everything is better to know a little bit of 3D. In 3ds Max I'm working for forever. It's my main program in 3D. It's not for electronics because I'm an artist. I know my artist tools, and 3ds Max was one of the first serious 3D software around, and after it came Proteus, which is having a 3D visualization of the circuit inside it, of the board of the tracks that you are making, and that's not really. I like 3ds Max is way more fast to create what I created here. Stuff like this, and because I have 2 resistors, I don't think you can actually see them. You can a little bit, but they are 2, one stacked, one on top of the other. You see that you see this light green resistor, and I have it there as well. You see it there underneath, and on top of it is 100 kilo that is in parallel with the LED, and it's part of the logic that I'm having here. And you can clearly see it here as well. 1 kilo is on the bottom there, and 100 kilo is here. So this kind of design, I made it already exactly like this in 3D before making it in reality, and I'm pretty happy with the result, and I hope you like it, and I will update you later when everything will be hopefully more stronger. I don't know, we will see. Here's the progress. This is another day, by the way. These are the transistors. I mounted them. I didn't wire everything yet, but I just mounted the transistors. One resistor here, and here on the circuit diagram I have it here, this resistor, and all these transistors that you see here. Actually they are 6, but here on the diagram I didn't have space to put the 6th one. I mark it there somewhere, but it's absolutely the same for everything. And so these modules are completed with this 6 module here. So 2, 4, 6 are completed with these transistors, which I put them separately. To be honest, I wanted to look interesting. I didn't put them in the same circuit with the button, because to maintain a small foot of the module that I have in here, the same footprint for everything, I was thinking. And also these are the transistors are very very big comparative to this small module, and they are, you know, enlarging it unnecessarily. So I thought I could put them aside. And also, to be sincere, I wanted to look interesting and funky. And when someone is looking on all of this, they will scratch their head. But in reality, it's very simple circuit, as you can see here. And in reality, after a few years, when I will look back to this circuit and I will not remember anything about it, I will scratch my head and I will say, what the fuck did I did here, if I will not have the diagram. So I will have to remember to put this diagram also with the circuit in the same package somewhere folded, you know. So this is it for now. Now I have the wiring. What I did, more importantly, I've added one kilo. This green blue color resistors that you see on all of those buttons are. So originally I put, actually here is saying 10 kilo. Oh shit. So this is a 10 kilo. This blue. Let me point it. So this green blue resistor is 10 kilo, but this small one is 1 kilo. So here on the diagram, those four. So this four here. 1, 2, 3, 4 are the clock pin, buttons. This button that is going to clock, and it's having here in the diagram is having 10 kilo over the LED, but in reality I put 1 kilo. I have to change this to correct it. Let me do it in a second actually. Okay, so I've corrected the values actually, exactly how I'm having them in reality. So this resistor for the LED, in my case, because I'm using old LEDs, I have to lower to increase the current and lower the resistance to the LED. And here on the clock I maintain the same 10 kilo. I hope I will not have to change it in the future, because everything is a bit different from the tests that I did there, because of the LEDs. They are the only thing that are different, but the rest I use the same transistors, pretty much in the same integrated circuits, but not the LEDs. The LEDs and their respective values are different from the board. These are high brightness and they are highly efficient LEDs. I don't think you can see them properly, but they are translucent. This translucent LEDs here and there, and they don't require too much current, and I can put 10 kilo on them. That's why on the diagram here it was with 10 kilo for those. But here in this case they are way more shitty, and some of them I should probably tweak the resistance even more for. But the problem is that I don't have this small resistor. These are scrapped resistors, and I don't have them. I didn't buy them, and I don't have them in other values, smaller values. Some LEDs are even weaker than the others, and I have to tweak a little bit to brighten them up to equalize the others pretty much. I hope I will be able to do it. If I will find either similar resistor size, or I will see. I will have to find a way with the SMD probably, most probably, instead of that. But in the future, that's not a major problem. For me, it's good that it's working everything. So far, this is what I wanted to show you. So far, it is working. Another important thing is this. I just did a test. Look at this. Look how it's bending. So this is how it's bending. If you are wondering how shitty my board is, you see how it's bending everything. How shitty is this? But if I'm careful, and I think I find out a solution, I will add a band or metallic band on the back. Of course, I will isolate everything here. I will put a piece of another cardboard, and on that I will glue another cardboard, and on that another cardboard I will put a sheet metal that will strengthen it very good. And that's for the future. I hope with only one cardboard I will be able to strengthen it, but I doubt it. But if I will be able to do it, that will be very good actually, only with the cardboard. And the ICs, they will have to go on the other side, or here in continuation. I have to decide if I will add them here or on the other side of the board. Usually it's not a good idea, and I know it from experience, to add on two sides, because it is complicating things, especially when you have to debug. If something is going wrong, trust me on it. It's very, very bad to do it both sides, and it's not easy to find the problem. It's a bit harder than when you have everything in your field of view, when everything is laid down in front of you like this. So most probably I will add them here in continuation, because they are only two guys, and that's it. And a lot of wiring that will happen underneath, most probably, under the board. A very interesting detail. Doesn't matter which transistor I link to which module. It really doesn't matter. I have them here because they are all linked. They don't have specific points. They all have only common points. And pretty much is like you are linking every emitter of these PNP transistors together with that line. Is together through that 10 kilo to the 9 volts, to the 5 volts. And all these collectors are linked together to the ground. And it doesn't really matter which transistor it is for which module. It doesn't matter. So I can link them this with this with this, or this with that, and this with that, and this with that, or this with this. And doesn't really matters. And it only matters these 4 buttons which are linked to which pin are linked. The 4 clock buttons here, because they must have an order. This is 1, 2, 3, and 4 clock pins. They really have to have an order, and the order I am deciding to link them from here, it will give me the final code. That's the hard part. That's the bad news, is the way I'm linking them. The code cannot be easily reset to something else, to another code, another number. You have to stick with what you have, and you have to remember it, of course. And that's the bad part. But the good part is that you have to remember the order, and also doesn't matter, all this wiring that I'm having here are all common for the emitters, common for the collectors, which is very interesting circuit, I may add. And yeah, it took me a couple of days to came to this circuit, and I couldn't make it in reality by myself if I wasn't having the simulator. The simulator helped me be good, you know, at using transistors and this kind of mechanics that I'm having here. This is thanks to a very good simulator that I'm using, the Proteus. I don't think others are equivalenting it quite good. I want to show you. This is in progress. This is the first common. This is the first wire that I put here in the entire circuit, and is the common ground. But look how is this common ground. This is ground for all the buttons, including these ones for the clocks as well, because it is ground and it's common to everything, and that's why it's called common ground. And here to here to here to here, because this is flipped, you know, is rotated actually 180 degrees, and they have this this configuration. And I actually had some scrapped wire. This is scrapped wire. And this is brand new, is lacquer. I don't know how to pronounce lac. In my language, you pronounce it lac, but in English, you have to split your tongue in half to pronounce some words. But this is scrapped. Both of them are scrapped actually. But this is damaged from a transformer that burned, and the excessive heat, made this wire very fragile and very breakable. If you bend it 1 to 3 times on the same spot, it will break extremely easily. In comparison with a brand new one, you can bend it like 10 times until it will break. But this one, 2 times or 3 times on the same spot, and it's quite fragile. And because it's burned, you can see it is. I know you cannot see it properly, but by comparison with this brand new that is shiny, this is matte. It's not shiny at all, because it is all the lac that is having on it is burned, is blackened. And what I did, I had a longer wire that split in half, and very extremely lucky, it was the exact length that I needed here, with a little bit of margin tolerance there, rest that I had, but I could put it everywhere with only one line. So I took my knife, and I put my wire, and I along, of course I keep it with 2 hands, but now I have to keep my phone in one hand to show you, and I scratched the entire wire, and I rotated the wire, and I scratched it again, and rotated it, and scratched it again, until I scratch it from all the nasty burn that is having, and I leave it as you see it right now. It's shiny because that's the unprotected copper right now, and it's shiny because the metal is shiny, not the lac that is put on it. This is the lac. Actually, is also the copper that is underneath that is shiny, and also the lac that is on top of it, the isolation. And they are both shine. This particular shiny effect, but this is pure copper that I have here, because I took care of it, and I have to make a test to see the if everything is connected. If I don't have an isolation point somewhere to check for conductivity, pretty much. But I put like this, and it's pretty good in my book. But I wanted to show you the way I put the wire like this, and it's smart. It's very smart. Originally, I thought to put a single long wire like this, like a bus bar, a bus wire, and from it to solder to each pin. But this is way more easy, way more fast and simpler to do it like this in a zigzag. Yeah, this is it for this part. And I had more burned scrapped wire like this. I had quite a good amount. Someone gave it to me, a lot of components, and also some wires, scrapped wires, and also some burned ones. He probably believed that was good wire, probably. I'm guessing. And but from random points, if you were testing the wire for isolation, it was conducting from random points. If you were getting along the wire with the probe of the multimeter that you set it on a continuity mode setting, and that's a big problem. You don't it's not recommended to use scrapped burned wire. It's okay if it's scrapped but is new. I mean, is having all the lac, all the protection, all the isolation on it, is fine. But if it's burned and is showing marks, serious marks of burn, you don't use it in a coil usually. But like this, you can definitely use it as a track. And be careful not to pass positive over a negative track that are isolated pretty much. But you have to design in such a way the board that you are making. So that's the point I wanted to make. I had a lot of scrap wire, and now I'm sorry I throw it away because I could use some different thickness and also length. I don't have that much remained, only this one and this one that I used already to scratch and desisolate it and use it as a track by itself, especially for the positive that I have to make right now. And I linked the positive of this 5 here, not this, only this. And I want to show you how I link them. I put a hole there. Let me point. So I put a hole there, also there, but I didn't use it. So diagonally, I put the wire like that for each pad, positive pad, and here and here, and also here. But on the other, you see, from here to here, from here to here, from somewhere there, probably that one, and this one here, and here, and here, probably only here because it's the first. So so I took the wire and I soldered it there. I put it through the hole, and on this other side is linked to that hole, and it's coming out from here, going down through that hole. I soldered it. Then actually I made the boob, and I put it through the hole. I drag it, but I leave a little bit here, and I use my tweezer and move it around and position it, and then solder it, and then go to, and this is how it's looking on the other side. Go to the other, and the last one. So all these 5 right now at this point in time, they have positive and negative. And theoretically, if I'm pressing this button, the LED should work if I'm connecting a negative and a positive somewhere there. And yeah, I think it should work. Yeah. The other mechanics are for the rest of the circuit there, but by itself, the positive LED resistor and switch to ground, that's the only thing that I can test very easily soon enough. Said and done. I linked 5 volts there. There it is, 5 volts. And if I'm pressing the button, every LED is lighting non-uniformly. Some are weaker, some are stronger, but it's good enough. And yeah, it's Houston, we are in business. All right. Oh, I linked the positive there to here, and all the positive wires here, and every button is lighting. The first line there, and the second line here as well. Pretty awesome. And yeah, it's only through, so the circuit that I'm having linked with wires right now, I'm having positive here, resistor, LED, button, and negative for the clocks here, the 4 clocks, and also positive, LED, resistor, button, negative is the same as there, as here, you know, is exactly the same circuit. This is a completely other functionality for the same button, pretty much. When you press the button, it's doing 2 things. It's doing the LED plus resistor, lighting an LED pretty much, and also driving this reset, common reset. All the reset are put to ground, to negative, to 0 volts, to logic low, to logic 0. The same goes for every other button. That's the function of them. So, but right now is half of the function because I didn't link them to any integrated circuit, and also I didn't link them to the transistors. Also the transistors, I have to link them to ground. And you probably thought putting the wire to bases to all of this, all these 6 transistors, the wires, it was hard. But remember, I have to put ground wires and also this common wire that is going to actually to this pad here. I marked it as air for reset. So all the emitters from the transistors, I've actually marked every transistor that I have, emitter, base, and there is collector. And they are all facing like that, emitter, so emitter, base, collector, and all the collectors are down here, and all the emitters up. And I can link them, and I should probably do it this way as well, link them together, all the collectors between them, and all the emitters between them, and only one wire going to here to the reset, and that's it, probably, most probably. And only separate base wires to each, all the 6 modules for everything. Yeah, hope you like it. I like it. I want to add that this is a devious circuit. It looks easy, but it's quite hard to make it, and I smash my brains, and without some proper tools like Proteo simulator and also 3ds Max that I managed to make the modules to create them, I don't think I was getting such a beautiful and quite compact you know, element, board, cardboard that I have here. Pretty interesting, very interesting project actually. Yes, I realize I made a mistake in design. I could have linked collector, and also collector, the single pad for the collector, and the single pad for the emitter for all of this. So in parallel like this, collector to collector and emitter to emitter, collector to collector and emitter to emitter, collector to collector and emitter to emitter, and one single pad without having I put these links already here for collector to collector and also to emitter. As you can see, they are linked, but I could have make a single pad. That's a mistake. I didn't think of it. I'm not perfect. I was thinking modularly, you know, one step at a time, and that's the way I'm doing things. And I am planning ahead but for the big picture, not for every detail, possible detail that I have. So probably in the next version I will have to make the proper adjustment, but not really. It will not be a next version for sure. Yeah, interesting mistake I did. All right. Let me open it. 5 volts. Let me link it here, and I've made some modifications. I put the positive wires here. I linked the positive to everything that was there, negative to everything that is in the middle actually. And also some logic wiring here, pretty much all the emitters between them, and linked to this reset pin, exactly like it is here in the diagram. So all the emitters are linked together, and also linked to this point in my in my board here. And from this point it will go to each reset of the chip of the ICs, and they are waiting there. And also the common collector, each collector is linked there by this green wire. I actually marked on the board, so emitter, you see, collector, and everything is like that. It's easy to do it. And yeah, all the emitters are linked together, and this wire here, because they are crossed like that, you know, is crossed here to the emitter, and this is the 0 volts, the ground, all these green wires, and because this is crossed here, it is crossing there to that common wire that is zigzagging that way. I only have to put the base of each transistor to its corresponding 10 kilo, which is under there. And I believe, yeah, it's a bit confusing how many pins I have here. This is the pin of the button, actually, the leg of the button. This is the pin, this is the leg of the 10 kilo resistor, which is under this 100 kilo, which is in parallel with the LED on top here. And under it is the 10 kilo, which is linked. I will have to make a hole there to the base of the transistors. And pretty much that's it for this. And then I will have to add the IC. But all the resistors, the LEDs, the switches are already made. Also these modules here. And we will see. Also, I made a test. Everything is working fine. And this is a weird ball, but it's good enough. It's lighting up, which is good. And everything is lighting up. Like I said, only the LEDs through that 1 kilo resistors. That's it for this stage. But other logic will come next. I hope you like it, how it's looking so far. I do like it. I like it very much. And it's pretty interesting. Also, I had to test in this time, with this project, I've tested my newly attachment that I'm having there, and is working absolutely gorgeously. This new soldering iron that I made a switch here for it, and is powering up, as you can see, it's sitting up. And by the way, it is a wood, let me close it. It is made from wood, this cube here, but nothing from the metal itself is touching that wood. It's only catching in this plastic. It's very fit to this plastic, and all the metal is floating, perfectly centered in that hole that I'm having, is exactly in the center of it, not touching anything. Because I looked, I did check it, because this is very tightly fit. It will auto-center itself, and it will stay quite straight. And I was testing this arrangement that I'm having here, and it is absolutely awesome. It is a little bit of problem with the wires, especially for this one when I'm doing this. You see, it's grabbing the other wires, but it's very quickly making itself. Is not dragging is not dragging down anything. Is making space for itself a little bit in the beginning when I'm taking it out. But other than that, is absolutely okay. And this is absolutely having no issues with the wire, because it is on the top wire, and absolutely cool. I had to test this as well with this project, and having two of them in the same station, it's very handy. It's very handy. Yeah. Thanks for watching, and see you later, alligator. All right, and the LEDs are working absolutely gorgeously. Okay, good. All the LEDs are good. I made all the connections for this board at least, so everything is connected, and I made the setup here. This circuit is already built from before starting everything. And now I'm getting this reset wire to one of the resets that are already they are linked together there. And when I'm setting, this is I made a test here. That's why this LED is lighting when I'm pressing. When I'm releasing, is closing off. It was to test one module like this. And when I'm pressing one to whatever how many, but especially one, if I'm resetting all the 6. So from here to here, they are doing the job absolutely fine. It's resetting. I'm having a little bit of problem with this guy here. For some reason, I have no idea why he's not resetting. I have to check it out. But not all the time. Sometimes it's doing funny stuff. And of course, you cannot see the LED when I'm pressing like this. This is a bad design. But probably if I'm putting it, mounting it on vertical, you know, and when I'm pressing, it will be left and right the LEDs for each LED. If it's like this horizontal, you are covering with your finger the LED, which is not good. But very bad design if it is like this. But if I'm putting it on vertical, it will be fine. So this is what I'm doing here. I'm testing the reset. Of course, these last four here are not doing absolutely anything, because they are setting. Like I'm pressing here, this is set, and lock everything. And this one of these 6 is resetting back to 0, which is absolutely gorgeous. Awesome, awesome, very, very, very cool. I really like it. That is functioning at this stage. Right now, it's good to make tests in the building process, you know, to test like I'm doing it here. Right now I'm testing all this board and it's functioning absolutely fine. I'll have to check. I already find a bug probably. This motherfucker that is not always resetting. You see, it's not always resetting, but every other are doing his job absolutely perfectly without any problem. You cannot see that leading at all. But yeah, when I'm clicking, but this guy this is the bug here, a little bit of bug, but I will resolve it. That's why it's good to make tests in the process of building the board, the cardboard. So yeah, it's good. It's good. Now I will have to add this to chips somewhere. I have no idea where. Probably also here. It will be a bit longer than I anticipated, but it is what it is. It is a test, a way of learning about flip-flops, about logic circuits, at least for me. And it's good if I'm making it a project in itself, and it's cool. It's cool that it's working, and I checked it, and I double, triple, tens of times check it, and it's good. I'm on the good direction, on the good path. So yeah, oh yeah, thank you very much. And I find the problem with this module here, why it was not working. The link, it was very, very devious, and I find it quite quickly, the problem. How I'm finding the problem is I'm grabbing the pins, the connections, the wires that are there, and with my tweezer and jiggling a little bit to see if it's loose. And if I'm seeing it moving around from the soldering, it means that it appears that it's soldered, but in the back, underneath it is just floating, and from the top, when I'm looking down to it, it is appearing like it's soldered, but in reality it's just a spring, exactly like my tweezers, you know, springing, floating, and not making the actual connection. And that was exactly the case there. You see this little wire here next to this green wire. Let me actually zoom in. Yeah, and it was a shorter wire link here. So from here to here, and when I mounted this green wire, that little thing was springed out, floating a little bit over the solder, and it was too short. And this green wire soldering there kind of moved out that connection. And I changed it. I took it out, that link, and I put a longer link right now, and it's making an absolutely perfect connection. And that moved when I pinch it with my tweezer. When I grab it like this and I wiggle it a little bit, I could see it was moving. From its position from that link there, not from here, and that's how I managed to debug the problem. This is reset. This is set, and now if I'm resetting, it's absolutely working from one push. So it was my mistake. It was a connection mistake, and it wasn't from this module. Thanks God. And yeah, it's absolutely working from one push, exactly like the others. I have to do it with one hand, and it's working fine. That's the very small update, unnecessarily probably, but stuff like this. When you are building stuff, you will encounter, and especially in my case, this is a very special case that I'm using. Everything is scrapped. Every component that I'm using is not new, is scrapped, including the buttons. Here, everything is new here on the breadboard, but here are scrapped, and that's another potential problem. Using scrap components, it's another variable that you have to keep in mind. I was thinking maybe the transistor is gone, but I did test every transistor before mounting them, and they all give me good values, also recognized as PNP by my transistor tester that I have there, and that one. Not that one. And that's I was thinking maybe he burned out somehow, but no, these are actually very strong to overheating, and if you are lingering, if you're staying too much with iron on their pins, they are quite tough, they are quite resistant comparative with the newer transistors that are made today. I'm not promoting them at all. I don't like them because they are too big. I am a SMD pro. I am pro SMD. I really like to work with SMDs in general. But these are scrapped components that I have them for a very long time, very, very long time, decades, probably 20 years or so. You know, they are just staying there and doing nothing in my drawers, and now I'm putting them in function. And yeah, they're pretty much this is it. Everything is working fine, and yeah, I repaired it. All right. So this is a small update. I want to show you how I'm catching these ICs on the cardboard, because this is a cardboard. But before I'm telling you how I'm catching them, I will show you how it's looking behind it, how the wires are looking, all the connections here, and there. And I put some paper, I literally glue some paper to isolate the other wires underneath, and also the pads, the ears of the pads that are coming from here, from these transistors, on this other side, and not to make possible shorts between all these wires that are coming after them. That's what I'm showing you here. Now back to ICs. What I did, this is how they will be mounted, like that. And as you can see, there is a tiny space under the leg. You see, it is a tiny space there. It's not touching the cardboard here, the leg. So it's a bit higher than it should. And you can actually, let me zoom in. Yeah, you can see the shadow. You see, it's a little bit of space there. And I wanted it like this. It's by design like this. And Why? Because if I'm touching the cardboard when I'm soldering wires to the pins, it will burn the cardboard and it will make a big, nasty brown spot like here, like I'm having there. And how I did this thing, it's very easy. I have some scrapped paper here, and this is a rest. This is a rest. I took a longer paper. I fold it, and as you can see, my camera. Yep. You can do it. So like this, you see, it's folded all around, and I make it flat all the time. I maintain it flat. So I maintain it flat all the time, and I was maintaining the same width that I need for my chip to be onto it. And then I cut the two pieces. It was longer, and I cut in two pieces. These two pieces here, and I glue them with with a very mild, very mild glue. This is very liquid. This is very viscose. This is more viscose and is stronger. Is much more stronger. And with this, I will glue the chip to the paper. Paper differential. But with this mild glue, which is mostly water, it's high percentage of water, I glue the paper to the cardboard because it's paper on paper pretty much, and it is very good, extremely good on gluing paper between them. I don't have to use this super glue, which is a bit more stronger than that watery thing. And that's it pretty much. I put the viscose glue here, I'll link it there, I will press it there, make it uniformly even, like that, and then I will have to add the wires to each pin of the IC. I hope you like it, and also leave a like. Alright, I made a very small test right now. I've only linked one single flip-flop here, and I had to modify a little bit the circuit. I had to take out this pad from here and put it here, and also I had to drag a very long wire from here also to this pad here. It's not that I don't have pads, but when I'm leaving it on in the circuit, it means it's doing something important. And at this point, I could link the resistor directly to the common emitters that I'm having there, I believe. Yeah, and the copper wire that you can see there is this very long wire, very long. It's the longest here. From you see it long until here, and it is a mess of wiring on the back. It is deviously simple. This circuit is deviously simple. It's hard. It's a bit harder than I expected. And then I linked this reset. It's called here clear, but it's actually is the inverse, not reset. And this is how I'm testing everything. So I power it to 5 volts there, also not there. And this is how I test it. I have this. This is my tester right here. It's 2 pieces of wire, a solid wire that are staying put. And here is a small SMD resistor and a LED, brand new, and they are linked together like that. And it's quite fragile. I have to be careful not to fuck it up. And here is the positive. I mark it with this yellow thing, and this is the negative. Also, I mark it with this black shrink tube. Yeah. And I'm putting the positive and negative to negative. Here is the negative of the chip. I put the power of the chip as well on this one as well. It's having a negative and positive on these 2 pins, as you can see here, positive and negative. And the output is this Q here. And I'm putting pretty much the positive on the Q and the negative on the common negative that I'm having there. And just to make a small test. And when I'm pressing this button, because the link is to this button, I don't see it. It's too long. So yeah, it's trembling like that because I'm not making very good connections here. When I'm pressing the reset, it will reset, and when I'm pressing the button, the set, I hope. Yeah, you can see it. Actually, I can bend it like this a little bit more. You see? So let me make better connection if I can, like that, probably. So this is set, and either one of these buttons is the reset. When I'm pressing there, if I'm moving, nothing happens. And only one, like I said, only one flip-flop from here is connected on the chip itself. Come on, make connection there. This is set, and either of this is a reset. Doesn't matter which one I'm pressing, and it's working. That's the point of this, you know. And I will have to test the other one when I will link it all together. But for now, I wanted to test to show you this little, very simple device, simple probe. is a logic probe. This is a logic probe. It's telling you if it's working or not. You know, when you're doing stuff like this, pretty much. All right. I managed to link the second flip-flop from the IC. So is this and this, and only these two, and these two are on the other chip there. But this is fully linked to everything. I already tested it, and let me show it to you how it's working. This is my logic probe here, and let me erase it. I don't know what I did. I put some markers there where the pins are to probe. So this is first, as you can see. You cannot see, like that. Reset. So first digit, and on here, on this and this is nothing. It should be nothing. Yeah, that's another pin. But on Q, the second there, and the ground. And now when I'm pressing this button, it's opening this specific one. And let me reset it. So 1 and 2. And voila. And there's cascading one after another. Yeah. My logic probe. Holy shit, I don't believe it. I can't believe it, but I finished it and it's working absolutely gorgeously. Absolutely gorgeously. Exactly as in the simulator here from the circuit diagram. And yeah, right now it's powered to 5. So let me introduce very quickly the code. 1, 2, 3, come on, and 4. And voila, that little shit opened. And any other here button from here is reset. Doesn't matter which one you press. Absolutely fantastic. Absolutely fantastic. Holy shit. I'm so happy. I'm so happy that I finished it. It was quite hard. All those white paper that you can see there are to protect the wires, not to make short between them. The ones that are on top with the ones that are on the bottom that are protected. Pretty much I glued a piece of paper, ordinary paper. I took it, I cut it, and I glue it with my my very watery glue for stamps. This is what it means. Litige de timbre. It means a glue for stamps, you know, for postal stamps. But well, it's not really for postage stamps. I name it like that because it's very weak. It's very good for paper in general. If you have to glue paper on paper, it's absolutely cool. And here is cardboard. This is from on the other side is paint. This is paint, and that adhesive is not that good, but I still use it. Is also watering the paper, is making it extremely soft and extremely malleable, and I can make those tracks, you know, with my finger, with my nail, or with something pointy, with my knife, like pressing very easy. So yes, that's a little detail there. That's not that important. What is important? Let me close to make a better. Yeah, I will film it like this because it's good enough. Let me rearrange a little bit. Those are the wires that I used, cut wires. I had a lot of them, and I kind of reuse them everywhere here. So let me introduce the code again. Here I'm having a bit more contrast. 1, 2, 3, and 4, and voila, how beautiful it is. And I don't need button debouncer at all, because all the debouncer is happening in the chip itself. In the moment you click once here, these are the buttons, the 4 buttons for the clock. I'm clocking, pretty much I'm creating a clock, and when it's clocked, this data pin, and this output pin, from output to data pin to the other data pin of the other flip-flop, once it's set up, once it's triggered from only one click, doesn't matter how many times the button is bouncing by itself. When you press it, it is creating a little bit of fluctuation, a couple of I don't know, 5, 10 little contacts, more contacts than the original you intended to do. But doesn't matter because once this is set up to 5 volts to positive, this is latched, and you can press multiple times. I can actually show you. Now it's reset, doesn't matter. So doesn't matter how many times I'm pressing here on the first button. It will count as only this open. That's it. And now when I'm pressing the second, it's counting this one, and it's open here on its output, and it's activated this guy here. Number 3, this one, I press it here, and it's activated this one. This one is expecting, this is waiting for its clock, and when I'm pressing here, voila, there. Absolutely gorgeous. Super cool, super cool. I had to bend here, let me close it from wherever. As you can see here, probably you cannot see that well. Actually, I can zoom in, and you can see that pin, I had to bend it up. It is bent up like that to make room for the leg of the LED to go on that pin. And that's it. I wanted to show you about this part, and I wanted to show you, yeah, on other side how it's looking. It's a lot of wiring, as you can see, a lot of wiring, and I will have to probably put another glue paper on there, and just for precaution, not to catch the wire and drag it by mistake. Just a couple of, you know, a couple of papers there to secure it more better, more better, and then I will probably have to make some sort of case to encase everything. And also I was thinking to add an electromagnet that will, or a solenoid is called, that will actually, or a motor, a small motor I was thinking, and activate it for a few seconds, like 1, 2, and that's it, the motor, and or 5 or 10 seconds to stay open and then to close or something. I'm not sure how I will do it. A small motor that will disengage a lock somehow. I'm not sure yet. I'm not sure if I will do all of this. I'm very happy I finished this quite deviously easy circuit. It was easy on paper, but very quite hard, and I had to work very slowly and with a lot of attention to all the details to not fuck it up, and it worked from the first try. Absolutely, I'm very happy. I'm very happy. But also thanks to my prototyping board, that thanks to this, because it's better to test before here, and I double check it in my simulator as well, and it worked there as well here in the breadboard. But here in the final version that I'm having right now, right here, is gorgeous. It worked from the first try. I can't say how much I hate when something is not working on the final board that you are designing. It's absolutely pain in the butt. If it's a wire that is loose or something, that's no problem. But if it's a component that you misplaced, you have to rearrange all the thing because you made a stupid mistake. That's absolutely hell. I don't like that at all. And I'm very happy that it worked fine from the first try. And I'm super cool. I'm super happy. I know the code. The code is very easy to break. Probably, most probably. Another very important thing: you have to hardwire this clock wires, the clock pin to the mechanism, to the button mechanism. So I literally dragged a wire from this flip-flop part side of the chip to that. The other side of the chip is another flip-flop, and I drag the wire here to this button. So this is the hard wiring, depending how you want the code to work. And I wanted it like this: 1, 2, and 3, 4, like that. Pretty much like I'm pressing with one finger. 1, 2, 3, 4. Let me reset it, whatever. So 1, 2, because this will be vertically. Also, I want to mention, yeah, this will stay on vertical like this, pretty much, to not conflict when you press the button here. To actually, when you are staying, you cannot see the LED. This is very stupid design. If it's on horizontal, it must be on vertical. And so 1, 2, 3, and 4. Yeah. I'm very happy it worked. Wow, what a project! What I wanted to say. Yeah, I used for this project. I know I'm repeating myself, but I used 95% of the components that I used are all scrapped, exception for these two chips that are brand new and I have them in my inventory. But all the LEDs, all the buttons, they are not even the same. Most of them, you see, this one is having a little thing here, this one is not, also not. This one is having, this one is having, and so on. And also the color of the buttons. This is a bit more black. This is a bit more grayish. These are also a bit more blacker. You see on the button, and this is a bit more grayish. They are very quite random, and some are quite used, and some are almost brand new. I can hear them how they are clicking. And these are very old transistor PNPs transistors that I used. I used them there as well. And all the resistors, of course, are scrapped. Especially these little guys that helped this project. Actually, they were very good here, and I couldn't insert bigger resistors, but I did insert those overlapped there. That you see, one on top of the other. And yeah, pretty much. Also, this red LED is scrapped as well, that resistor. And also the wires, all the wires are scrapped. And this is a cardboard, if you didn't figure it out already. This is a Colgate cardboard from a package. Okay, so yes, that's it for this project. Probably I will make a case, secure case, a more sturdy case, because right now you see how bendable everything is, because it's too long and the cardboard is not. And you see those wires are not really secure there. I have to do something about these problems, the bendability, how bendable it is, to make it more stiff and more serious, and also to protect those wires not to catch and grab. And I have no idea if one of those wires on the back is coming loose. I have no idea from where is connected. So that will be very bad luck. Let's see if it's still working right now, because I bent it. Yeah, it's working. It's good. It's an indestructible circuit. This one is very good. I cannot praise it enough. I really love it. That it worked from the first try. That's why. All right, I hope you like it. I hope you like my project. And yeah, leave a like, motherfucker. Don't be a motherfucker and leave a like. And see you soon. All right, bye bye from your favorite artist electronist here, Mr. Q12 from Romania.